Friends, I am Professor Rekha Agrawal, School of Education, Central University of South Bihar, Gaya. Here with you to share some of my experiences regarding the decisions I took statistically during the preparation of the sketch of institutional growth of my previous organization. During this course, I had to answer one of the questions that what level of IQ the newly admitted students, which were more than 1000 of my organization, were having. I selected and paired 2 postgraduate students of my college for working to get answer of this question. It was one of my student centered approaches of teaching, in which I usually assign students some meaningful activity and product based collaborative work. It was also, of course, was like that. Both of them started working on the project. I was not directly involved with them. First of all, they worked to finalize a standardized group test of general intelligence to gather the data. It was a paper pencil test and the average norm of this test was 115 IQ. Then a sample of 100 students was selected randomly by using blindfold technique. They collected the data by using the standardized general intelligence test collectively in 2 rooms. After organizing the data, it was treated to get its mean. The sample mean was obtained as 123 IQ. They compared the sample mean with the average norm of the test, and it was found that the sample mean was greater than the average norm of the test. Both of the students reported to me that they had completed their work and the level of IQ of the newly admitted students was very high. Actually, both of them were not well acquainted with the inferential statistics. Therefore, I told them that the value of sample mean may vary if they take another sample of the same size from that group and repeat the same procedure. And therefore, even if apparently it was clear that the IQ level of the newly admitted students was higher than the IQ level of the entire population, it may not be definitely concluded that these are the true values. Actually, this statistics was not sufficient for me to state that the newly admitted students were truly having higher IQ level than the average, because the sample of these students was the only one amongst the so many other samples we could have drawn from the group of the newly admitted students. Suppose we had replicated the study several times. On each replication, we would have randomly drawn a different sample from the population. Because of the sampling variation, the same mean may not be expected from all the samples. The value of mean, the sample statistics, would have been probably different from sample to sample. Therefore, it was not justifiable to infer the value of the population mean when we had only one sample mean out of many different possible sample means. Both the students were curious to learn how to reach to the conclusion. I then directly started working with them. We first translated the question into a statistical hypothesis. They had a query that what it was. I told them that what result we are expecting from the data, we have to test it statistically. Only then we may be able to rely upon them. One of the students reacted immediately. Oh, you mean to find out reliability of the mean which we have calculated? Yes, you are right, I said. It is necessary to know the reliability of the mean because it may have some deviations from the true value due to some kinds of error which might have incorporated due to some or other reasons. I explained to them further that the mean value they obtained is the sample statistics and the value of the average norm of the general intelligence test is called as population parameter. In our case, the value of sample statistics was 123 IQ, that is the mean of the sample, and the value of the population parameter was 115 IQ, which is the standard average value of IQ on the test. If nothing is manipulated and everything remains normal, then we may hypothesize that the mean of IQ level of the newly admitted student shall be the same as that of the population. Realizing the technicality of the work, I myself directly got involved into the further processes and also explained to them reasons of doing so. I hope that by this time you must also have become a part of this discussion. Let me state further. To examine the validity of my hypothesis, I framed a question that what sample mean would occur by chance if samples of the same size were drawn at random from entire group of newly admitted students. If the hypothesis that the population mean is 115 IQ is true. I envisioned a theoretical random sampling distribution of the sample mean for an infinite number of samples of size 100 drawn from a population whose mean is 115 IQ and compared my sample mean with the means of that sampling distribution. You may see this sampling distribution on the screen. Suppose my sample mean was placed somewhere as has been shown in figure A, which is not very far from the population parameter, that is the mean of the sampling distribution, which is not very far from the population parameter, that is the mean of the sampling distribution. In this situation, I could be able to infer that my sample mean was 1 that could reasonably occur if the hypothesis was true and would have retained the hypothesis as a plausible possibility. On the other side of the story, the situation of my sample mean could also be as it is shown in figure B. This is almost at the end of the sampling distribution. Here in this case, because of the large amount of the deviation of the sample mean from the population mean, the probability of obtaining such a value by chance would be quite unusual when the hypothesis is true. Therefore, I would have rejected the hypothesis and concluded that it is more likely that the level of IQ of the newly admitted students is not 115, but is higher than the normal value, the average mean of the population. The hypothesis I tested presents the normal status of the case. This normal expectation from the data is called as the null hypothesis. We often denote null hypothesis as H0 and pronounce as H naught, H null or H0. It is also called as zero or pseudo hypothesis. In inferential statistics, the null hypothesis is a general statement or default position that there is nothing new happening. Like in my case, it is stated that the level of IQ of the newly admitted students is 115, the population parameter, the normal mean value. We assume the null hypothesis to be true until evidence indicates otherwise. We may analyze the way how a defendant in a jury trial is presumed innocent until proven guilty by evidence presentation in the court. The evidence for the happening may be acquired, but the evidence for being normal or non-deviation may not be sought. Therefore, the judgment of the jury always guided by the evidences presented for the deviations from the normalcy. Drawing analogy from the mechanism of the court, hypothesis testing starts by stating and assuming a null hypothesis, and then the process of evidence determines whether assumption is likely to be true or false. The important point to note here is that we are testing the null hypothesis because there is an element of doubt about its validity. Whatever information that is against the stated null hypothesis is captured in the alternative hypothesis, which we denote as H1. In my case, the alternative hypothesis could be that the level of IQ of the newly admitted students is not equal to the population parameter, that is 115 IQ. My alternate hypothesis was expressed as HA is not equal to the population parameter, that is 115 IQ. You may note it here that both null and alternate hypotheses are always the statements about the population parameter and never about the sample statistics. Our decision to reject or retain the hypothesis is always referred to null hypothesis and never to alternate hypothesis. It is null hypothesis that is subject of the test. Now you may pose a question: what criteria are used to decide when to reject the null hypothesis? You must have noticed that when we drew a random sample from a population, our obtained value of sample mean was almost never exactly equal to the value of the population parameter. It is because when we draw a sample randomly, chance factor plays a vital role in fetching errors to the data. The magnitude of the deviation of the sample mean from the population parameter was the criteria of my decision to reject the null hypothesis. My sample mean was so different from what was expected when the null hypothesis was true, and the chances of its occurrence were more. Therefore, I rejected the null hypothesis. You may now ask, what degree of rarity of occurrence is so great that helps in deciding when to reject the null hypothesis? Here, I would like to mention that it depends on the decision of the researcher, that how much precision he wants to bring in his statement. However, the common research practice, especially in behavioral sciences, is to reject null hypothesis if the sample mean is so deviant that the probability of occurrence by chance in random sampling is 5% or less. We call this criteria as level of significance. The levels of significance are denoted by the symbol of Greek word alpha. Actually, this was the level of significance only which I used as a criterion to decide that my sample mean had a low probability of occurring by chance if the null hypothesis was true, and hence I rejected the null hypothesis. I used the level of significance of 0.05 level, where chances of occurrence of the value of true hypothesis was maximum up to 5%. If you look at the figure C, you shall find that 2.5% portion of the sample distribution is separated from both the ends, which exhibits its 2.5% upper and 2.5% lower region, specifying the total 5% of the area of the sampling distribution. This is the area where only extreme 5% cases may fall, and therefore, this area restricts the happening of the normal cases and rejects the possibility of finding the null hypothesis true. Therefore, when I found that the value of my sample mean is located in this area, I rejected the null hypothesis, and because the value of my sample was higher than the population parameter, I retained the alternate hypothesis that the level of IQ of the newly admitted students is not 115. You may question me further, but before you ask, I would myself mention here that we may assume the random sampling distribution as the normal distribution curve, and hence may use the normal probability curve to calculate the z value of the score, which separates the upper 2.5% and lower 2.5% sample means from the remainders. These z values are called as critical values as well, and may be found plus minus 1.96 z scores in the table of normal distribution values. Here, I shall further specify that I could be even more stringent and would have used the level of significance of 0.01 or less. If I had to use these findings in preparing some more detailed layouts or programs or otherwise. If you see the table of normal distribution values, the critical value at 0.01 level of significance is plus minus 2.58 Z scores. Both of the students remained active and curious throughout till we reached the end. But it was not an end, because my students were very much eager to know that what these Z scores are, how they are figured, how to use them for taking decisions statistically in different situations to reach a conclusion. Do you also have this query? If yes, we shall work now together. Let us take up some assignments to proceed further. We shall start with a small data. Are you ready? Okay, let us start. I have asked my students to work in pair. You also make your pair for our regular work assignments. Note that there are 30 students in my class. Last month they were given a test on which their scores ranged from 3 to 8. You also jot down, please. Look on the screen. Now write frequencies in front of these scores. I am also writing. For 3, the frequency was 1. For 4, it was 2. For 5, it was 7. For 6, it was 7. For 7, the frequency was again 9, and for 8, it was 2. You now compute the mean and the standard deviation of the data. Now you finish your work. We are meeting in the next session to work on this same situation to get the answers posed by my students. Okay, bye.